Welcome to the lab demonstration on stacking with Ruckus ICX switches. This demonstration specifically covers stacking on the ICX 7250 switch. Different models of ICX switches have unique rules on stacking, including which ports can be used for stacking and which ports are the default ports for stacking. The ICX 7250, the 10 gig license is required to perform stacking. This is because we use ports in slot 2, ports 1/2/1, and 1/2/3 to perform stacking. These are the default ports. So in order to use those ports, we have to have the 10 gigabit license. So let's take a look at the license on our switch here and make sure that we have the requirements to perform stacking. So here we have the 10 gig port on demand license, and we have a capacity of 8 ports. For stacking, you only have to purchase the 2-port license that allows ports 121 and 123 to be enabled, that allow stacking to operate on the switch. So let's go ahead and get started and configure stacking. We start configuring the stack or enable stacking with the stack enable command. So we'll get into configuration mode. And run the stack enable command. This command instructs the unit to start actively participating in stacking and also disables optical monitoring for the stacking ports, again 121 and 123. So to enable the stacking operation, we have to disable the optical monitoring functionality. This happens automatically, but there will be no optical monitoring on ports that are configured as stacking ports. Okay, so now that that's ready, we can run the stack secure setup command, and this is what actually reaches out to the other devices. I have 3 switches in this stack connected using stacking cables that I will discover by running the stack secure setup command. So we do this from the privileged exec level of the CLI, so we have to get out of configuration mode. So we'll exit out of this and run the stack secure setup command. This command actively goes out and starts looking for devices down on the stacking cables to identify them as potential members of the stack. So what we found here is 2 ICX 7250 switches that are connected on the stacking cables. So now the question is, do we want to include all of these units in the stack? So yes, I'm going to go ahead and select 2 here and say that I do want both units to be added to the stack. Now, it's going to go through and look at those units and start identifying, putting IDs to associate with each switch. Each of these switches will have a unit number. So ports 1/2/1 that we identified on our switch, the second unit would be 2/2/1 would be the equivalent, and the third unit would be 3/2/1. So I like this configuration. I'm fine with it. We're going to have a unit ID of 1 for the unit I'm on, and a unit ID of 2 for the first one it found down the line, and a unit ID of 3 for the next one it found down the line. So we'll say yes here. And now it'll start building out the stack. First thing it'll do is it'll assign itself a stack priority, this unit, a stack priority of 128. And then an election will be held. Although in this case, there is no real election to be held because it's the only unit in the stack at this point. So in that election, it has the highest stack priority, and the other devices have a default stack priority of 0. So this device will take over as the active unit of the stack, and then it'll go out and instruct the other units to reboot into the stack with a default configuration for all ports. So essentially the other units will come up, all ports will be enabled, they'll all be put in the default VLAN, and everything will look exactly like they would if they were a brand new switch, only in this case they're now a member of a stack, of a 3-unit stack, where this one is the active member, and it will assign roles to other members of the stack as they come up. So we can actually get in and look at some of this process while it's running in the background. So let's go ahead and take a look here. We'll run the show stack command and see where things are at right now. So right now we're looking at ourselves as the only unit in the stack. We're waiting for other switches to come back up, so they're not quite up yet. But once they do, they'll be active members of the stack, and then we'll be able to start seeing information about what ports they're connected through, what state they are as members of the stack, and things like that. So now we see these units coming up and becoming active members of the stack. So let's go ahead and take a look at these real quick. Show stack. So now we see that we have 3 units in the stack. We have the active, that is us, that's a switch that we're actively connected to with a priority of 128, and the others are priority of 0, and they're just members right now. So if you see down here, the switch is going to work on assigning a standby. It's going to go through a process of determining which switch should be the standby, and it'll have that determined in the next 47 seconds, or 47 seconds since that command was run. But we do see here is that we have the active unit 1. It's connected from port 23 or 1/2/3 to port 2/2/1 on the second switch. And then its port 23 is connected to the 2.1 port on the third switch. Now let's take a look at our configuration while this is still going on, because the system's still assigning a standby. Well, actually, it just completed, as I said, that the standby unit 2 is now the standby unit. So before we go and look at the running config, let's take a look at this output again, and we see we have a standby switch for unit 2. So when we look at our configuration, we can see in here that now we have all 3 stack units in the configuration, unit 1, unit 2, and unit 3, and the stack ports that are being used are enabled on those units that the stack is enabled. And then we see here on unit 1 that the priority is 128. Like I said, it's skewed in the favor of the unit that we run the secure setup command. It assigns itself a priority of 128. Now we could go and assign other units priorities to have a preference if we have a failover. If you look at the stack MAC information here, what this is the MAC address that's used for the entire stack. That allows a unit to take over if the active unit fails, and we'll use the same MAC address, so we wouldn't have to learn MAC addresses or re-ARP to learn how to reach these switches at their MAC address. Another thing that gets configured automatically when we run this in this version of code is the Hitless Failover enabled. So again, this allows a unit to take over as active if the active unit fails, and take over all functionality of that previous active unit, including that MAC address, IP information, and configurations like that. So that's stacking on the Ruckus ICX switches. We've enabled a stack of 3 switches here. It was a very simple process. You run the stack enable command on the first unit you want to configure for stacking. You make sure your cables are connected properly between each switch, and then you run the stack secure setup command and wait for each unit to run through the process and identify its role within the stack. Thank you for viewing this demonstration.